part 2 of the POCASA interface rundown, but I got to do a quick bit of change around here. Do some of that. Start. Okay, and it's running. ID is 0.5. So I'm going to go ahead and change it to 0.6 just because I made some changes here a minute ago. And it goes a fair amount quicker this time around. Let's compile that real quick. Hurry up. $76,532. 58.5% of the flash is being used on the PIC. Let's go ahead and do the update. It's the X version. There it goes. While this is running, left side of the screen is pretty much the same. I added a raw text input. Type it in there, hit that button, and it sends raw text out there to test new commands that I programmed in the PIC rather than cutting a new button for it and all the code that goes with it. Anything that comes back will come up in the text box here. Clear the text box there. This here is the input window for all the XY read data that's coming back from the PIC. Yeah, again, nothing's changed here. You got the clear button there, clearing the thing. Okay, there we go. Now we're waiting. There's the Windows USB disconnect sound. Wait 5 seconds. And 0.6, and it works. Okay. Over here we got the channel switches off button, DDS channel ground. Pulse generator. DDS is direct digital synthesis. That's my sine wave out or triangle or what have you. Channel 0 through channel 15. So I got to make a deal that says if this channel is equal to this channel or this channel, then don't select that channel because you don't want all these channels. You don't want any of them to be the same as the other ones. Bad things happen to the circuit itself. You can turn them on, turn them off. You turn them all on. You hit this button to turn them all off real quick. Down here, the RS switches, that's the source resistance. Yeah, the lower the resistance, the more current you can push through the circuit at a given voltage. Same thing here, turn them on, turn them all off. They go to really high impedance. Here's the DDS, the generator, the pulse generator, or the sine wave generator. I haven't made one for the pulse generator, which I'll put over here. Pulse generator generally used to trip relays or transistors or MOSFETs, or just inject a signal somewhere else so you can see the output of it while you're putting in your other signal, your DDS signal, your sine wave, whatnot. Turn your DDS on and off, change your signal from sine wave to a triangle. MSB1 and MSB2 are a divider of the main crystal frequency going into DDS, so /1 would be 24 megahertz, /2 would be 12 megahertz. DDS has 2 registers in there, so you can switch back and forth between the frequencies. Right now I got them set to a preset frequency of 60 hertz and 400 hertz. Switch between them like so. Turn it on, select your frequency. These counters go from 60 up to 12 megahertz, or yeah, 12 megahertz. So right now I'm using 400 megahertz. I want to switch to 60 and read that. I want to switch to 400 and read that, and so on. Down here is your gains for your op amps. That basically changes the voltages throughout the system. DDS gain, DDS offset. That's your source signal. DDS gain basically sets your voltage. Offset sets where that signal is centered around the 0 point. So a higher number, push it higher above the 0 point. A lower number, push it below the 0 point. At some point, you're going to be all positive or all negative rather than swinging above and below 0. Pulse generator gain, pulse generator offset, same thing there. The voltage that's coming out and where it sits around 0. X gain, X offset, Y gain, Y offset. That would be how it's displayed on here. Say you have a really small signal in here, you turn up your gain in X, and it would be a bigger signal here. Maybe you want to get it to fill up the whole screen so you can see it better, so you can see a little more detail. Same thing with Y. You get it to fill up the whole screen. The offset would slide it left or right or up or down. Maybe you want to get that thing centered so you can maximize the screen or maximize the input so you can see a little more detail. And down here you preset them to 0 for minimum voltages, minimum gains. Maybe you're initially plugging something in and you just want to dial them up real slow so you can get them all maximized. And set it to mid-range. Maybe you don't know what you're dealing with. Digital pots off, digital pots on, reset. If you're at 0, you reset them, it resets back to a mid-scale. And this is the business over here. This draw button down here just puts dots on the screen just to see that it's working. I get one signal here, or one XY reading here. I dial this up. Here I get 217 in a row. Not grabbing anything right now because the analog to digital input isn't hooked up to anything. Here I grab 1024 XY samples. Again, in a row, just 1024 of them. And if you watch over here, you can see how long it takes to grab 1024. Start. Done. Read random, I got a couple, and read sequential, I got a couple of commands inside the PIC that just say, hey, dump me back a number. I don't care about the ADC, just give me a number. So I hit random, it shoots me back 100 random points just to see that this is all working. Same thing as sequential. It runs up and down the y-axis here and then slides over to the x. Slides over 1 on the x. It just keeps going. If I hit continuous scan, it'll keep scanning in the background and give me 1 point. Now I'm going to clear this out and you can see it grabbing 1 point here every second. Or it should. Maybe I broke something. Entirely possible I broke something. Nope, there it is. Okay, right down here. If that's 1,000, this is a number of milliseconds between scans. So if it's 1,000, it's once every second. If it's 500, it's twice a second. 330 would be 3 times a second, and so on and so forth. I get down here to 1. It'd be pretty close to 1,000 times a second, although it's not quite that fast. Because if it was, it would be filling up 2 of these lines every second. So I got to tighten up the code just to make that a little bit quicker. See, as I'm going up here, it's not quite slowing down yet. Okay, there it just slowed down. So it looks like the maximum I'm getting here is about 6 scans per second. And that's okay. DDS-PG monitor, that's your that monitors the peak voltage of the sine wave coming out for your signal generator and your pulse generator. Kick that, kicks me back a number here. That's your ADC input at the PIC itself. And turn it off. Oh, it's still scanning. I guess I got to fix that. Yeah, still scanning, so I got to fix that too. No biggie. Clear the window. Yep. Okay. And that's it.